subtraction, and addition is always the best. So next, like I said, we're going to talk about the multiplication of fractions. And we did a little bit about this above without even discussing it. It must be way up there. But essentially, it doesn't matter what our numerators and our denominators are. They don't have to be the same. We're just going to multiply the top by the top, the numerators by the numerators, and the denominators by the denominators. So we'll go numerator times numerator, and denominator times denominator. That is basically all we do. So, some quick examples to practice. 1 over 3 times 2 over 5. It's going to look numerator times numerator over denominator times denominator. 1 times 2 is 2. 3 times 5 is 15. 2 over 15 is our answer. And it's in lowest terms, which we always like. Another example here. 1 over 2 times 12 over 16. Again, numerator times numerator, denominator times denominator. You get 12 over 32. Now that definitely doesn't look like it's in lowest terms, so I know that they're both even, so I can divide by 2. 6 over, well, we already did times 2. 6 over 16. Again, even, so I can get 3 over 8. And that's probably as small as we're going to get, so we can leave it like that. One last example before we hop onto division is 1 over 2 plus 3 over 2 times 5 over 12. Now, big things to remember here. We have multiple things happening, so we need to remember precedence. Precedence is bed mass. Brackets, exponents, division, multiplication, addition, subtraction. So, we have multiplication and addition. Which comes first? The multiplication. So we're going to take a look at this stuff first. So that's 3 times 2. Oh, no. 3 divided by 2 times 5 over 12. Again, straightforward. 3 times 5, 2 times 12, gives me an answer of 15 over 24. Now if we rewrite what we had above, we get 1 over 2 plus 15 over 24. Now remember, we have to have the same denominator for addition and subtraction. Now the cool thing here is 24 is an even number, so we know that 2 can times by something to get us to 24, so we should only have to change this one guy. So we know 1 over 2 times 12, 2 times 12 is 24, should give us that denominator. 12 times 1 is 12, 12 times 2 is 24, which is what we need here. So then I can rewrite below 12 over 24 plus 15 over 24 is 27 over 24. Awesome, that's pretty well a good answer, but if we take a look at it, our numerator is greater than our denominator, and what that means is we have an improper fraction here. So we can simplify this answer further by changing this into a mixed number. And how do we do that? Well, 27 divided by 24 is 1 and a bunch of decimals, but we ignore them. Okay, so now we know that 1 times 24 is 24, and 27 minus 24 is equal to 3. So our answer is 1 with the remainder 3. And then we just take this here and we can write it as 1 with 3 over, the original denominator, which is 24. And that is our simplified answer, 1 and 3 over 24. Next, we're going to talk about the division of fractions. Again, more fractions. All we can talk about is fractions today. So division. Division is interesting because we're really going to end up just multiplying. And you'll see what I mean with this example here. So I have 1 over 2 and I want to divide it by 1 over 6. Now, first what we're going to do is we're going to take this second fraction, and it's always the second one, the one after the division sign, and we're going to flip it. We're going to find the reciprocal. So what that means is we're totally taking 1 over 6, which, if we remember from reciprocals, is just 6. Or 6 over 1. So then what we're going to do is we're going to come back to this original, and we're going to go 1 over 2, and now we're multiplying by this reciprocal, 6 over 1. And again, just basic multiplication like we did above, 1 times 6, 2 times 1, so we get 6 over 2. And 6 divided by 2, we know what that is, that's 3. So that's our answer for 1 over 2 divided by 1 over 6. So our big takeaways from here, I can write down in steps for us. 1, we're going to flip the fraction following the division sign. And then we're going to multiply. 2 steps. Pretty simple. There we can see it in writing. We're going to give it a couple more tries. So, next example, 1 over 8 divided by 1 over 4. First step, flip this guy. Flip it 4 over 1, which really is just 4. And then we're going to multiply 1 over 8 times 4, our new flipped fraction, which is 4 over 1. Might be easier for us to see. So 1 times 4, 8 times 1, 4 over 8 is the answer. Now again, this is an in lowest term, so we can go further and go 1 over 2. Another example, 2 over 3 divided by 5. Now, just because this one isn't a fraction doesn't mean we don't flip it. Okay, so because we're dividing this fraction by something, whatever this something is, we have to flip it. So flipping this is just 1 over 5. Because if we think about it, 5 is just 5 over 1. So flipping it, we get 1 over 5. So we can come back down here, 2 or 3 times our new buddy over here, 1 over 5, gives us 2 times 1 over 3 times 5, which is 2 over 15. And that is in simplest terms. Our last example for dividing fractions is kind of the opposite of the last one. We're taking 3 and we're dividing it by 1 over 4. Now again, just because this one isn't a fraction doesn't mean there's no flipping happening over here. Okay, because we have a fraction, we must flip. So we take this over to the side, 4 over 1, or 1 over 4 becomes 4 over 1. Then we can come back down, and we take the 3, we're multiplying by our new buddy over here, 4 over 1. And we remember, 3 is also the same as 3 over 1. So we're getting 3 times 4 over 1 times 1, which is 12 over 1, which is really just 12. Pretty straightforward. Next, we've got addition of mixed numbers. So we talked about mixed numbers. We talked about how to get mixed numbers from an improper fraction and from an improper fraction to mixed numbers. So now we're going to add mixed numbers. So The simple steps for us here, and I'll write them out so we can see them. First, we're going to add the whole numbers. Pretty straightforward. Then, we're going to add the fractions by finding the LCD. And our last step is to add the sum of the whole numbers to the sum of the fractions. And what this means is we're just going to take that whole number and place our fraction beside it. Okay, so it's best to explain with an example, so we'll just hop right into an example. So we're going to take 2 3/4 and we're going to add 3 1/2. So our first step was add the whole numbers. Here's my whole numbers. 2 plus 3 is 5. And we're going to kind of just save that for later. The second step was adding my fractions. So I have 3/4 plus 1/2. Now they're not the same, so we have to switch this half to make it 4 because we know we can. So I get 3/4 plus times 2 on this one, on this side, so 2/4 gives me 5/4. And then my last step is to take my whole number and add it to my fraction. So my whole number's here, this 5, so I'm taking 5 and I get 5/4. Now that's pretty well our answer, but we can see there's something wrong because this is an improper fraction. It shouldn't be an improper fraction because we're using mixed numbers. So what I can do is break off this 5/4 and change it into a mixed number. So we know to do that, 5 divided by 4 is 1 and change with a remainder of 1. Which means that we're from here going to get 1 and 1/4. Okay, so now we're really just going to have to add 5 to this because that's the only whole number we have left. So I'm just going to add the whole numbers together because that's how we add whole or mixed numbers. So I get 6 and 1/4, and that is my full answer. Now, if we don't like that way, if that way might be a little bit confusing, adding our whole numbers, there is an alternate way we can do this. So, our alternate way, we have 2, if we write down the question again, 2 and 3/4 plus 3 1/2. Now, remember, this is what we're going to end up with at the end. Okay, so, actually we'll write that down. It's actually equal to 6 1/4. But what we're going to do is we're going to change them into improper fractions, add them, and then change them back into a mixed number. So I know that I have to multiply here and then add 3. 2 times 4 is 8, plus 3 is 11/4. Keep that the same, right? The same one here. Same here, 3 times 2 plus 1. 6 plus 1 is 7. 7 over the same denominator, 7/2. They're not the same denominator, but we can change them. You can change this one particularly, so I get 11/4. Again, we're just timesing by 2, so I get 14/4. And if we add those together, we get 25/4. And then we're just going to change them into a mixed number. So I get 25 divided by 4 is equal to 6 with remainder 1. And that gives us 6 with 1 over original denominator 4 as our answer. So you have 2 choices on how you're going to accomplish something like this, and that is to convert our fractions into improper, or we can just add the whole numbers together and do it that way as well. So I'll do one more example with doing both ways, just so we can kind of get used to it. So this next example is 3 3/4 plus 2 5/6. First, I'm going to, well, I'll start by changing this into improper fractions first. So 3 times 4 is 12, plus 3, 13, 14, 15/4. 2 times 6 is 12, plus 5 is 17 over the same numerator or denominator, which is 6, 17/6. Those two are not the same, but we know that 4 times 3 is 12 and 2 times 6 is 12, so we're going to get them both multiplied up here to get what we need. So 15 times 3 is 45/12 plus 17 times 2 is 34/6. Oh, not 6, 12. We need 12 down here. 45 and 34 is 79/12. And if we were to go 79 divided by 12, we'd get 6 with remainder 7, which means that this is equal to 6 and 7/12. Okay, and to write it again, we're looking for 3 3/4 plus 2 5/6, and we already know that we're looking for 6 and 7/12. We're going to add our whole numbers, so 3 plus 2 is 5, and then I'm going to add our fractions. Again, we're going to want this to denominators to be 12, so I'm multiplying by 3 for the first one, so I get 9/12 plus the second one's multiplied by 2, so I get 10/12, which gives me 19/12. 19/12 is really 1 with remainder 7, so it's really 1 and 1/7, and I just need to add 5, our whole number, up here to it, which gives me 6 and 1/7, which is, oh, I did something wrong. Let's look back here. Remainder 7. Oh, that's the problem here. I wrote it as 1 remainder 7. We gotta make sure that we do this portion right. 7, remainder 7 becomes our numerator, over original denominator 12, which gives us 7/12. Phew, there we go. Now they're the same. So as we can see, we can do it either way. The nice way with doing both is that you can double check your answers like I did here. But again, you're going to use the way which works best for you. Okay, the last thing we're going to talk about today is the subtraction of mixed numbers. And it's a little bit different than adding, but I promise you it's really not that hard once you get used to it. So again, let's start by writing out our steps. So first, we're going to start with the fractions this time, and we're going to find our common denominator first. And this is because if our first number, so it's going to look question mark minus question mark, we'll call this question mark 1 minus question mark 2. If question mark 1 is smaller than question mark 2, we'd end up with a negative fraction, but those really are not something we want to use. So what we might do is grab from our whole number to make this number bigger so that we end up with a positive fraction, question mark 3. And you'll see how that works when I show you an example below. So yes, first step, finding a common denominator for our fractions. Second step, subtract those fractions. That's the step where we're going to double check our whole numbers. Third step, we can subtract our whole numbers. And then we're going to combine them together to get our mixed number. Pretty straightforward, but you'll see I've got a couple examples here. So, example 1. 15 3/4. Subtract 8 and 5 over 6. Okay, 1, we're going to look at those fractions. 3 over 4 minus 5 over 6. Not the same, but again, 4 and 6, we know we can get to 12 here. So we end up with 9 over 12, minus 10 over 12. Now yeah, here's our first example. 9 is less than 10, so we'd get a negative, so it would actually be negative 1 over 12. We don't want that. That's a gross answer. So what we're going to do is we're going to make this 14. And what we're going to do is we know that we have, so technically we have 15 right now. 15 and 9 over 12. So if I go down to 14, then I get to add 12 to my numerator. Because 1, if we remember, is 12 over 12 is equal to a whole number 1. So if I have 14 and something over 12, we know that there's 14 12s in there. So if I take one away, I can add 12 to my numerator. Okay, so what this means, I'll get rid of all this stuff in here so that we can see a little better. Well, remember that this is 14 now, and over here then we have 9 plus 12. Oh, excuse me, it's 21. So now I have 21 over 12 minus 10 over 12, which is 11 over 12. Now, our next step is just subtract those whole numbers. So remember, I have 14 instead of 15, so I have 14 minus 8, which is equal to 6. And now I can combine them. So I have a whole number 6 and a fraction of 11 over 12. And that's a proper fraction, so it doesn't need to be switched, which means this is in lowest terms, and therefore the correct answer. Okay? Now again, we can do this as well by changing these numbers into improper fractions, and just as we did above, and subtracting them that way. But I wouldn't advise that. You could do it yourself and double check if you get to this answer, but I'm not going to show that way because it takes a little bit more time. You're usually multiplying very large numbers that you wouldn't really need to do if you were to stick with this route. Okay, so we're going to just show examples this way. So my second example is 10 and 2 over 6 minus 5 and 4 over 3. So again, we'll start with those fractions, 2 over 6 minus 4 over 3. 3 can just be changed to 6, so we'll end up with 2 over 6 minus 3 times 2 is 6, so 4 times 2 is 8. 2 minus 8, again, here we go. We've got to steal a couple of whole numbers here. So I'm going to drop this to 9, and I'm going to add 6 to this. So I end up with 8 over 6 minus 8 over 6, which is, 0. There's no fraction on this answer. Interesting. So then all I have left to do is take my whole numbers, 9 and 5, which gives me 4. And my last step is to combine 4 with my fraction, but 0 over 0 isn't a fraction, so my answer is just plain 4. Awesome. So for this one, this one has small enough numbers that you'd probably be able to do it in a way of changing things into what's the word I'm looking for? Oh, improper fractions. Okay, so I mean, to get you started, I guess I could kind of help out with this. 10 times 6 is 60 plus 2, 62 over 6, minus 5 times 3 is 15, plus 4 is 19 over 3. And you'd, of course, still do the same thing, right? You're just multiplying by 2, so it'd be 62 over 6 minus 19 times 2 is 38 over 6, which gives us 24 over 6, which is just 4. So the same answer again, right? Like I said above, I'm not going to do it with some of the bigger examples because you're going to get numbers like, I think this example that we did previously ends up with like 189 over 12 and 106 over 12. So that would be 83 over 12 when you subtract them, and I mean, I don't know my 12 times table is great. If you had a calculator you could do it, but I don't know. I just find it easier to stick with mixed numbers, but that is, of course, your choice. So that's kind of everything we're going to go over today. I do have some last examples that we can try where you can pause the video, do it yourself, just to double check that you understood everything that we went over this class. So I will get right to that. So I'll write the question out, I'll give you a second to pause, and then I'll just go through the question. So question 1, find me the lowest common denominator of 2 over 12, 4 over 9, and 5 over 6. So go ahead, pause the video, I'll give you a few hints. So lowest common denominator, just like finding our lowest common multiple. Okay, so if I got started here, 2, not 2, goodness, 12. Denominators only. Good review for me too. Lowest common denominator, so we're looking at denominators. So I have 12. And then we have 12, 24, 36, 48, 60, and so on. We have 9, 18, 27, 36, and so on. So from here we can already tell 36 could potentially be our answer, but we gotta double check with 6 first. 6, 6, 12, 18, oop, that's shared, but who knows. 24, 30, 36, there we go, that's the one we want right there. Because even though 18 is shared here, there's no 18 up for 12, so it can't be 18. But they all have 36, so our lowest common denominator, our LCD is equal to 36. Pretty straightforward. Okay, question 2. This one's about reducing fractions. Yay! So I want you to reduce 72 over 112. Go. So remember, if we start off here, they're both even, so I can divide by 2, which gives me 36 over 56, and I can divide by 2 again, which gives me 18 over 9, 28. We can divide by 2 again, which gives me 9 over 14, and that's our answer. Pretty straightforward. Again, we could also find the greatest common factor and divide by that. But who knows, maybe you don't know the factors of 72 and 112 by heart, which I wouldn't expect you to, so it's perfectly okay to just divide by 2 all the way down, because we know that they divide by 2. Question 3. Mixed number to improper. Alrighty. So we're going to take 14 and 56 over 60, and I want it into an improper. So remember, got some multiplying, some adding happening up in here. Pretty straightforward, but we'll get right to it. We're going to go 14 times 60, right? Whole number times denominator. That is 840. And we're going to take 840 and add the numerator, which is 56, which gives us 896. And we're going to take 896 and put it over 60, our original denominator. Now we can definitely make this into lowest terms because we can tell they're both even, but I don't want to divide by 2 forever. So I'm just gonna let you know that our greatest common factor is 4. So our final answer is going to be dividing both by 4, which gives us an answer of 224 over 15, and that is in the lowest terms. Good on you if you got your lowest terms. If you not and you ended at 896 over 60, that's fine too. Those are some big numbers, hard to find common factors for. You could have also definitely used your calculator. That is definitely your choice to make on how you practice. Okay, so question 4, I do believe this is. We're going to do the opposite. We're going to go improper to mixed. And I want you to do 179 over 11. So again, some dividing, followed by some, I guess not really some adding, some subtracting, if you want to check that. So yeah, we'll get right into it. 179 divided by 11. Don't expect you to know this. It is 16 with a bunch of decimals, but again, we don't need those decimals. So how do we check what the remainder is? We go 11 times 16, and then we double check first what 11 times 16 is. I'm actually going to use my calculator. So that's 176. And 179, minus 176 is 3, so our remainder up here is 3. And that means that we can write our improper fraction of 16 and 3. Remainder becomes numerator over original denominator of 11. So 16 and 3 over 11 is our answer. And of course we double check that this fraction isn't improper. It is proper, so we can leave it in that form. Question 5. Adding and subtracting fractions. Just threw together one question that we can do at the same time to practice. So 1 over 5 minus 1 over 16 plus 3 over 8. So awesome, we have more than one thing. You might want to take a look at BEDMAS. But who knows, you probably know it by heart, so we know that we can do our subtraction or addition first. I'm going to start with subtraction. So I'm going to go 1 over 5 minus 1 over 16. 5 and 16, if you're unsure, the greatest common multiple is 80. So this is going to end up looking, we're going to end up multiplying to get by 5 by 16. So I get 16 over 80. Subtract 16 times 5 is 80. So I get 5 over 80, which gives me 11 over 80. And I can bring that down because I have to add 3 plus 8. So I have 11 over 80 plus 3 over 8. Pretty simple on the bottom here. We can just multiply by 10 to get 80 on the bottom, which gives us 11 over 80 plus 30 over 80, which ends up being 41 over 80. and that is in lowest terms. Oh, over 80, not 81. 80. There we go. That's question 5. Question 6 is adding and subtracting mixed numbers. Again, I threw them together to save us a little bit of time here. So we have 12 and 3/4 plus 5 and 3/8 minus 6 and 18 over 20. That's a big one. Again, bedmiss, doesn't matter where we start. I'm going to start with my addition. So I'm going to go 12 plus 5 is 17. And then I'm going to look at my fractions. And I'll end up with so I have 3 over 4 plus 3 over 8. 4 times 2 is 8, so I'll multiply by 2 to get 6 over 8 plus 3 over 8 is 9 over 8, which ends up being, since this is an improper fraction, you can do it yourself, but it is 1 and 1 over 8. So I can rewrite my question as 1 and 1 over 8 minus 6 and 18 over 20. Subtraction, we start with fractions first. Fun fact, the common factor of 8, or lowest common multiple, of 8 and 20 is 40. So I'm going to 8 times 5, and I'm going to 20 times 2 on both of these, which gives us 5 over 40 minus 36 over 40. Again, crazy, this is greater than that one, so we need to grab from somewhere. So we end up getting rid of 1. Oh, we forgot to add up here. I was confused. I was like, it shouldn't just be 1 here. We forgot to add. So on this one, we actually had to add 17. So hopefully you caught that on yours. So what this is we have to add our whole number. It's that last step to the other one. So this is 18 and 1 over 8. Yes. So this is actually 18 and 1 over 8 minus 6. So if we need to drop 1 here, so it's 17. And we'd add 40 here. There we go, that makes more sense. So then we'd end up with 45 over 40 minus 36 over 40, which is 9 over 40. And then if we look back up here, our whole numbers are 17 minus 6, which is 11. And we can add those together, so we get 11 and 9 over 40 as our answer. And that's in smallest terms since our fraction is proper. Okay, one last question. That was a long one. What was number 6? Okay, one more question, number 7, and we'll call it a day. And that's multiplication and division of fractions. So again, put them together just to save us some time. So the question is 3 over 4 divided by 2 over 5 times 22 over 25. And again, we can think about bedmess, multiplication, division. Doesn't matter which order we do them in. I'm going to do division first, just because it's easier, it's more fun. So I'm going to do that. Remember, with our division, we're taking the reciprocal, the flipped version of the second one, and multiplying it. So 3 over 4 times 5 over 2, which gives me 3 times 5 is 15, 4 times 2 is 8. I'm going to leave it improper because I'm going to multiply it by 22 over 25, right? And that'll actually end up giving me 15 times 22 is 330. 8 times 25 is 200. And that'll be my answer. Of course, we are here in mixed numbers, or in improper fractions, so we might want to change it to a mixed number, but this is a pretty big number to change to a mixed number. So what I'm going to do first is I know that both of these can divide by 10. So I'm reducing before changing to a mixed number. So I'll actually end up with, if I come over here, 33 over 20. And now I'm going to change it to a mixed number. 33 divided by 20 is 1 with a bunch of decimals. Again, decimals don't matter. So we actually have, I gotta erase this. We'll have a remainder of 3. 3 or 13? 13, goodness. Yes, because I have 20 times 1. This is always how we double check the remainder. 20 times 1 is 20. And 33 minus 20 is equal to 13. So 13 is my remainder. And then if I go to write this, 1, our remainder is our numerator and keeping the same denominator. So the answer is 1 and 13 over 20 for that last question. I hope all of this was super helpful and you understood everything. If you had an issue with any of these answers, definitely feel free to re-watch the video. I hope that this helped, and I hope you enjoy studying in the rest of your course. Awesome. Bye.
Sometimes you need to go and take a step back to see the truth around you. From a distance you can tell